Today's math lesson is 2.7, and we are going to be learning how to use addition properties. So you need to find a blue, lime green, and this violet red that turns like this pink. The blue I have, if you have it, is Bluetiful. And then yellow, green, and violet red. Pause the video and make sure you get your journal set up. Let me just scroll down so you can see. It says using addition properties. When adding numbers, you can group or change the order of them to be able to use mental math and solve the problem more quickly. So you can see that my chart does not go to the very bottom of my journal. It leaves about 9 lines, 9 empty lines at the bottom for me to do some more work. But you can make your chart going down and label your chart associative and commutative. So pause your journal and get it set up. Sorry, pause the video and get your journal set up. So the first thing we're going to learn about is the associative property of addition. So we first need to understand what the word associate means, because that is the root word of associative. So to associate means to group together. We'll just write group together. All right? So nothing is going to change places. We're just going to be moving our groupings. And in math, when we're talking about addition and groupings, we're talking about using parentheses. So we're just going to make sure that we know this with a star. Nothing changes places. Nothing changes places, just the parentheses move. That's going to be really important to remember. It says nothing changes places, just the parentheses move. Okay? You could even add the parentheses. So we're going to say just the parentheses move or are added to the problem. Okay, that is what it means. Let's go ahead and section that off with blue and just start doing some examples. So if I had a string of numbers, and we'll use decimal numbers since that's what we're focused on. If I had a string of numbers like this, 1.3 plus 1.4 plus 1.6. I can do this a couple different ways. I could stack it all up and it could take me a little while, or I could use one of these addition properties, associative, because that's what we're focused on, to make the mental math be quick. So when I look at these numbers and I know that they're all addition, I can use the associative property to group together numbers that might make the mental math come easier. So here's what I mean by that. Instead of working left to right, because all of these are addition, I can choose to place my own parentheses in there in a place that might be easy. So I can't change the order of them in this property, but I can change the grouping. So for example, if I were to put parentheses right there by the 1.4 and 1.6, I would have been making this a whole lot easier for myself because I know that 1 and 4/10 added to 1 and 6/10, I know that the 0.4 and the 0.6, 4 dimes, 6 dimes, are going to make one whole. 0.4 and 0.6 make one whole. And then I had the 1 and the 1 already, plus the new one whole. So let me explain that. So what I would do in this situation is I would go, okay, I'll take the 0.4, go ahead and circle it, and the 0.6, and I'm going to add those together to get one whole. Just in my head, I know that that's true. And then I take the 1 and the 1 and the 1, and I bring it down here. 1 and the 1 and the 1. So I have in these parentheses a total of 3 wholes. And now I can add the 1.3 really easily because 1.3 plus 3 wholes is, that looks like there's a decimal in front of there. There's not. That is just the number 3. Is 4.3. Sorry about that little smudge right there. A little frustrating. But what I did there is instead of stacking it all up, I just combined numbers. I grouped them together. I associated them together so that I could use mental math to get 4.3. Let's try another one. This time I'm going to use, well, let's just do whole numbers again. You ready? Okay. 49 plus 3 plus 97. That's my problem. Now I could do 49 plus 3 is 50, 51, 52, and then I could stack that up and do 52 plus 97. That's not what I want to do though. I want to associate or to group together ones that will make my mental math and my computations a lot easier. So here's the example. 3 plus 97 is easy. That's 100. And 100 plus 49, so much easier. 149. Look how fast that got done because I used the associative property. You cannot do this with subtraction. It is with addition that you can. And why you can is because it doesn't matter. For example, if I took 2 plus 3, I would get 5. But if I take 3 plus 2, I'm also going to get 5. It doesn't matter how I group them. It matters that I get the same answer. And so the associative property for addition is pretty awesome. All right, let's try one last one. And this time we're going to throw in fractions to the mix. You ready? Here we go. 2 and 3/10 plus, we'll go 2 and 3/10 plus 4 and 7/10 plus 6 and 1/10. So they all have the same denominator, which makes that a little pretty easy. But I want you to group together using parentheses the two mixed numbers that are going to make this a lot easier for you, that are going to equal a whole. So you're always looking for things that equal one whole or 10 or 100, things that end in 0. So 3/10 and 7/10, that would make a whole. So why don't I group together the first two numbers? See how I'm adding my parentheses in there? So that I for sure start in there. And I can just go like this. The 3/10 and the 7/10 made one whole. And then I have 2 and 4 make 6. So that means that in the parentheses I have a total of 7. And now I do the plus 6 and 1/10. Gives me 13 and 1/10 as my final answer. So again, using the associative property to group numbers together using parentheses makes this a whole lot easier. Okay, so you can tell we group these together and group those together. There's going to be situations where you can change where the parentheses are if you're only using addition. Okay, so look for that coming up in the future. We're going to move on to the next kind of property. This is one of my favorite properties. The commutative property, the root word is commute, and that means to move from one place to another. So we're going to go ahead and write commute, but we're going to use the math phrases for that. We're going to say that commute means to change the order. So that helps me remember because CO, commute, change order, CO. That'll help you remember commutative property. So when you commute, you go from one place to another. For example, Ms. Fisher commutes when she gets in her car and drives from her house to Bluffdale. And then I commute when I get back in my car in Bluffdale and go back to my house in Pleasant Grove. So it doesn't matter which direction I'm going, I'm traveling the same distance. The numbers don't change, whether I go from A to B or B to A. It's the same distance. So to commute means to change order. Okay, that's all we're going to say with this one. Reasons why you might to change, wow, I'm really having a hard time talking. The reason why you might want to change the order of something is to make your mental math a lot easier or quicker. So change order, that's what commutative means. We can use this whenever we use addition. Okay, if all the operations are just addition, we can use the commutative property. Here is an example. We'll just start with a very basic one. 3 plus 5 equals 8. And that is the same thing as if I were to go like this and to swap the order. So it is the same thing as doing 5 plus 3. They both still equal 8. So I can take the 3 and 5 and I can change the order and it still equals 8. Yes? Yes, it does. So that's a really basic example of that one. But let's get into some decimals. Let's go with it really doesn't matter what you're doing with this. As long as you know that you can change the order, then it makes sense. So I can go 1.4 plus 2.5 plus, I don't know, 0.6. And if I were to group these together, remember, associative is you can't change the order, you just put parentheses in. None of those, that's going to help me at all. But there are two I can see that if I were to put those two together first, it would be a lot easier with mental math. So what I do in this situation is I change the order. So I'm going to go, okay, 2.5 and 0.6. I'm going to take them and change the order. So I'm going to change the order of those two. So I'm going to keep the 1.4 and then I'm going to put the 0.6, then I'm going to put the 2.5. And the reason why I want to do that is so that I can just quickly work left to right, or I can go, okay, 0.4 and 0.6, those make one whole. And 1 plus the 1 plus the 2.5 is 4.5. Make sure you understand how I got 4.5. Could you explain it? 1 plus 1 is 2, and 2 plus 2.5 is 4.5. So again, that was an example of using decimals and changing the order in order to make the problem become mental math. Kind of nice. One thing you need to learn about the commutative property, so we'll draw a line under this one. One other thing you need to learn about the commutative property is that what it means is just A plus B is the same as B plus A. Okay? Do you think you could write that to the side? A plus B equals B plus A. It's the same thing. You're just changing the order. So let me give you an example. If I took 26,184, let me make sure I'm getting that number correct. 26,184 plus 1,546, and I tell you that that equals n. You put that in green, n. That equals n. Then what that really means is that I can take this and say, okay, actually I don't, well, yeah, I could say it like this. I could say that so is 1,546 plus, I'm reversing the order, changing the order, that is also n. See, look at that. I can just swap the two and it equals n. Okay? And then one last example. Sorry, we were going to do one more of this on the commutative side. One last example is instead of n being at the end, n can actually stand for one of the numbers. So we'll do a problem like this. 17.39 plus 12.58 is the same as 12.58 plus what? What would that abbreviation be? Well, we could put a letter in there like X or N or O, but it really is just going to be the other number. Look, I changed the order. Instead of having 12.58 second, I had it first. So that means the second number in this situation is 17.39. So using the associative and commutative property, we can make our mental math a lot easier in working with numbers. So you really need to understand the base 10 system. You need to understand what equals one whole and how to get to one whole or how to get to 100 or 10 the quickest ways possible. All right? Okay, we're going to do a couple examples down here at the bottom, and then we will be done with this side of the journal. Here is the example I want to do. I want to stack all of these numbers up. Are you ready? Here we go. 30,000, 20,000, 80,000. Wow, big numbers. 49,000 and 70,000. I want to add all those together. So I want to use the commutative and the associative property together. So I'm going to try to use these two colors together to make this work. Okay? So if I'm doing addition and I'm trying to use these two colors, I am going to change the order of some of them, which is commutative, and then group them together to make sets of base 10 numbers that are easy to deal with. Okay, so here we go. I could just stack all these up, sure, but I'm trying to make piles of 100 now. 30 and 20 would make 50. Do you see any that when you put them together, they make 100? I do. The top and the bottom ones, top and bottom. So if I take the 70,000 and I combine it with the 30,000, right? So I'm changing the order here. That gives me 100,000. And do you see another set that would make it 1,000? You don't have to change the order of these ones. They're right here, 20 and 80. So because I'm not changing the order, I'm going to use my associative. What do 20 and 80 make? They make 100, but it's 100,000. So I have another 100,000. So I've done the first one, second one, third one, and the last one. I just haven't done this middle 49,000 one. But I would leave it till the end because you know you have 100 and 100, which is 200,000 plus 49,000 is 249,000. So quick. I know a lot of you are going to want to resort back to the methods of adding on the right and moving to the left. But the point of today's lesson is not whether or not you can add. I know you can add. The point of today's lesson is being able to combine and change the order to show that you have number sense, that you know how to use these properties to make mental math happen. Okay, here's the last one we're going to try. They're decimals. 1.500. So 1 and 500 thousandths, 1 and 200 thousandths, 1 and 300 thousandths, and then I have a really weird one, 1 and 678 thousandths. And I'm asking you to add those together. Again, we're going to be changing the order and associating to make mental math. But instead of making hundred thousands, we're just trying to make one whole because these are all pieces. Okay? How do you make a whole with thousandths? You have to get these to all add up to be a whole, right? So here I go. Or you could take away the zeros really and think about it as dimes. Look at that. I have 0.5, 0.2, 0.3. Well, 0.2 and 0.3 make 0.5. So I could right now associate those together right now. The 0.2 and 0.3 make 0.500 or 0.5. But then I had 1 and 1. So I had 2. And now I can, look, I don't even have to change the order of these either. Now I'm going to go with this one to that one. I'll just show a little arrow. 1.5 plus 2.5. Well, the 0.5 and 0.5, guess what, everybody? They make a whole. 1.5 and 2.5 make one whole with just the 0.5s. So let me give you an example. So I'll just circle it. The 0.500 and the 0.500, those equal a whole. And then 1 and 2 equal 3. So what did those equal? 4 wholes. And then I just have this last one. So 4 plus 1.678 is 5.678. pretty great way for me to use the associative property to make this easier. I didn't have to change the order of anything. I just grouped those ones together first, kind of like putting parentheses over those two. So that is how you use the associative and commutative property to make your mental math a little quicker. In the next video, we are going to be going over the last property, and it's my favorite.